Hello, ladies and gentlemen. Time for part 2 of our quadratic forms. Last time we talked about vertex form for quadratics. Today we're learning about factored form. Last time we had this whole thing where you plug in the vertex, and you plug in a point temporarily to find A, and then you simplify things down and you get the vertex form and standard form. What we're doing today is dealing with a factored form, which looks like this. Which you might look a little familiar. It's called factored form because it's, well, factors. It's got your two binomials, like it might be like x minus 2 and x plus 5, things we factored before. So that's the kind of things that are in there. That's why it's called factored form. Well, those numbers in the factors are called p and q. And so those numbers are the x-intercepts of your graph. So if you were to graph a quadratic and you got something like this, the intercepts are the roots. They're the factors of that quadratic. So just one of them is p, one of them is q. It doesn't matter which one's which. You can have the left one be p, or the right one be p, and the other one just has to be the q. And so what we're going to do is kind of work through how to get all the pieces of the factored form in here and convert to standard form, because on all these I want you to get it down to a standard form. So here we have some information here. We're going to write out our function. It starts with f of x equals a times, and this is where it's different from vertex form. It's going to be x minus our p value, and then x minus our q value. And the p and q values are just the x values of the x-intercepts. So in this case, p is -3, and q is 5. Remember, when you subtract a negative, same thing as add positive. So I'm going to just kind of simplify that little piece real quick. It's x plus 3, and then x minus 5. And so here's my form so far. But I do need to still find out what this a value is. And so just like last time, we're going to take a point that it passes through and plug it in, just like it says here. You plug it into the, well, it's the x and then the f of x. I don't know why I put y here. F of x. So we're going to plug those in. Let me kind of change colors here. So this point is an x value, and it goes where all of the x's are. So it goes there, goes there, goes there, whichever one you're looking at. It goes in both of the x's. This is an f of x value, and so it's what you put here on the left side. And so let's go in and fill that in. So we got -3 for the f of x side, and then over here on the right, we got a times something plus 3, and then something minus 5, and that something is the 3 that's in there. All right, that's straight from the point right here. That's the x. So now we have these numbers in. We can finish solving for a, which is our next step. Let's simplify the right side here. 3 plus 3 is 6. 3 minus 5 is -2. And, well, 6 times -2 is going to be -12. So we can make it -12a. And we can divide both sides by -12 to get my a value of, divide, 1/4. Because, -3 divided by -12 is 0.25, or 1/4. You can divide both of these by -3. So we got our a value. Cool. Now we have a, p, and q. We can put them into the factored form. So this value is going to go in the a spot of my equation. So we got f of x equals 1/4 of x plus 3, and then x minus 5. Okay, so this is factored form. This is like, it's done if you just want factored form, but I do want to convert it to standard form. And so we're going to do a little bit of multiplying. Once again, deal with this thing last. It's easier to just like times everything by 1/4 than it is to like times it in and then times fractions times other things. And so do this part first. It'll help a lot. So let's do 1/4 of, well, we just have to do double distribution here. It's going to give me x squared minus 2x minus 15. If you're wondering how I get that so fast, I'm just like unfactoring it. So I know these two numbers multiply to be this one, and then they add to be that one. And that gives me my two numbers. So now I can distribute this 1/4 all the way through there. 1/4 of x squared is 1/4 x squared. 1/4 of 2x is going to be negative 2/4 x. And the last one is going to be negative 15/4. I can usually simplify here. The only thing that it does is this one. So let's go ahead and simplify that. The tiny bit that it does is just 1/2 x and then minus 15/4. And I am totally fine if you leave all your improper fractions. They're actually easier to deal with anyway. So we will leave it just like that. And our problem is done. It's now in standard form. Okay, so let's go through a couple other examples here so you can see it a few more times. Here's our first one. It says we have the x-intercepts of 3, 0. Well, that's not a whole lot of x-intercepts. Well, what's going on is this is both P and Q. Yeah, if you only have one x-intercept, it's like your parabola comes down, just hits once. You got just the single x-intercept. So we're going to put 3 in both these spots because that's the P and Q value. Well, we got it mostly set up here. We just need to find out our A value. So I'm going to plug in my point here. I need to take the 4 and put it in the x spots. And I need to take the 1 and put it here on the left. So actually I need to erase this. I need a 1 there. And I'll have 3 minus 3. Oh, sorry, 4. Sheesh. Mistakes, man. Mistakes. What do I get for going so fast? On the right side here, we got A times 4 minus 3. And then 4 minus 3 again. That actually makes this pretty easy. 4 minus 3 is 1. So this is A times 1 equals 1. So A is 1. It was like times 1 times 1. So A is 1. Hooray! That means we can take A1 and put it there in the A spot. So I got f of x equals 1 times x minus 3 and x minus 3. So this is the factored form. We need to distribute things down to get the standard form. Times by 1 does nothing. And so really I just need to times double distribute here. And so the way you distribute that, you can get negative 3 plus negative 3 to get the middle term. And then negative 3 times negative 3 to get the last term, which is positive 9. And now I got my standard form for my quadratic. All right, let's try out our next example here. I recommend that you pause and give it a shot on your own, and then come back and check. So let's check and see how things went. So we start by doing f of x equals a times x minus negative 3, which is plus 3. And then x minus negative 1, which is going to turn into plus 1. So here's this so far. We need to plug in, to find out the a value, we need to plug in 0 for those x's and negative 3 over here. And that's going to give me negative 3, 0, 0 equals a times 0 plus 3 and 0 plus 1. Well, that's going to give me a times 3 times 1, which is 3a, equals negative 3. And let's go ahead and just divide that 3 there. So we got a is negative 1. Cool. A doesn't always have to be a nice integer. Sometimes it's a fraction, just like we had yesterday, and that's okay. So I got this negative 1, which I'm going to put here in my a location of my function. So I got f of x equals negative 1 times x plus 3, and then x plus 1. And now I just need to simplify this. So this is the factored form of the quadratic, but I want in standard form. So I'm going to do negative 1 times x squared plus 4x plus 3. Remember, they add to be the middle one and multiply to be the last one. So it gives me my numbers. And now I can distribute my negative 1 through the quadratic there. We get negative x squared minus 4x minus 3 equals f of x. And that's my final result. So there you go. So there's some different examples of what to do with factored form. Your assignment is going to be that second page of the quadratic forms practice. It's part B. It's the one that has all, well, the x-intercepts that you use. So good luck on these. Once again, refer to the examples, refer to the notes if you get stuck. So good luck.